Arrays can be passed to functions in MATLAB. You can pass an entire array, meaning either a vector or a matrix, as an argument to a function. This is incredibly powerful. The result is going to have the same dimensions as the input to the function. So for example, here's a vector, which is a random vector, random integers in the range from -5 to 5. It's a 1 by 4 row vector. And what we're going to do is pass that vector to the absolute value function. So the absolute value function is going to go through the vector element by element and return the absolute value of each individual element. So the original vector, the input to the absolute value function, is 1 by 4. The result that I get is also going to be 1 by 4. Again, the absolute value of every individual element from the vector. There are a lot of really powerful functions that can be used to perform common operations on vectors or on columns of matrices. Min will give you the minimum value from a vector or from each individual column from a matrix. Max will give you the maximum value. Sum will sum all of the elements. Prod will give you the product of all of the elements. Cum prod and cum sum, those will give you the cumulative or the running products or sums. Here are some examples of min and max. Here's a vector vec. The minimum value of the vector is -2. Here's a matrix variable mate. The maximum value is going to go through the matrix column by column and give us the maximum from each individual column. So notice that when you pass a vector, the result is going to be a scalar. When you pass a matrix, you're going to get a row vector as a result. Again, it's going to give you the function on each individual column of the matrix. Here are some examples of sum and cum sum with a vector. So the sum is going to sum all of the elements in the vector. The cum sum is going to show you the cumulative or the running sum. So here's a vector vec which has the values 4, -2, 5, 11. Sum of the vector is just going to add all of the numbers together. 4 plus -2 plus 5 plus 11 is 18. If you want to see the cumulative or the running sums, we use the cum sum function. Cum sum of the vec starts with the original, the first element in the vector, 4. Then it adds -2 to give us 2. And then 2 plus 5 is 7, and then finally 7 plus 11 is 18. So the original vector has 4 elements. The result that we get from cum sum is also going to have 4 elements. For a matrix, again, it's going to go column by column. So here's a matrix that has random integers in the range from 1 to 10, a 2 by 4 matrix. Sum of the matrix is going to sum each individual column. So 1 plus 9 is 10, 10 plus 8 is 18, and so forth. Cum sum is going to show us the cumulative sum as it goes through the rows in order to calculate the sums for each column. So in other words, when we get the cum sum of the matrix, we start with the original row, 1, 10, 1, 4, and then we're adding the elements from the second row to that. So 1 plus 9 is 10, 10 plus 8 is 18, 1 plus 3 is 4, 4 plus 7 is 11. The prod and cum prod functions work like sum and cum sum, but instead of giving us sums, we're getting products. So here's a vector v that has the values 2, 3, 4, 10. The cumulative product of v is going to go through and multiply the individual elements and show us the running product. So in other words, we start with 2, and then 2 times 3 is 6, and then 6 times 4 is 24, and then finally 24 times 10 is 240. So again, the original vector has 4 elements. The cum prod function gives us a vector that has 4 elements also. For a matrix, for example, a prod of the matrix is going to give us the product of every individual column. 2 times 8 is 16, 2 times 7 is 14, and so forth. Since for a matrix, the functions operate column by column, if you wanted to get the overall value, then you would have to nest calls. For example, here's a matrix. If we get the minimum of the matrix, it's going to give us the minimum from every individual column. But what if we wanted the overall minimum of the entire matrix? Then we could get the minimum of the row vector that gives us the column minima. So in other words, the min of the matrix is going to give us 1. So that would be true, for example, of sum also. If you wanted to sum all of the elements in a matrix, then sum of the matrix would return the overall sum and not just for the individual columns.